Hello, today we're going to be looking at comparing decimals and looking at different ways you might be asked to compare decimals. When comparing numbers, decimals especially, it's nice to see them sit on a number line so that we can see where they sit in relationship to each other and whether they're bigger or smaller further down the number line or whether they're closer to a certain number. In this example, we have graph 0.8 and 0.1 on the number line, and then which number is closer to 1.0. When I graph 0.8 here, and I graph 0.1 here, you can see that the 0.8 is closer to 1.0. Since the question asks which number is closer to 1.0, I can safely say 0.8. In this example, it's asking graph 0.3 and 0.7 on the number line. Which number is closer to 0? Let's do that. Graph 0.3, graph 0.7, and now let's look for the number that we need to compare it to, so 0.0. As we can see, 0.3 is closer to 0.0, making my final answer 0.3. In this example, we're now looking at hundredths. It says graph 0.43 and 0.49 on the number line. Which number is smaller? Let's start by graphing these two numbers, 0.43 and 0.49. And as you can see, the 0.49 is further down the number line, making it the larger of the two. So, which number is smaller is 0.43. Again, in this example, we have hundredths. So we're first going to graph 0.89 and then 0.94, and we're going to see which number is smaller. So, graphing 0.89, 0.94, and as you can see, 0.89 is further to the left, making it the smaller number. This question is asking to graph 0.5 and 0.45 on the number line. Which number is smaller? So we're going to find 0.5 first. As you can see on this number line, there is no 0.5 there, but there's an equivalent decimal, 0.50, right here. When I graph that and I look for 0.45 here, I can now see that 0.5 is further down the number line, making 0.45 the smaller number. Be careful to slow down on questions like this. When you first see it, you might assume that 0.5 is smaller than 0.45 because 5 is less than 45. But when you turn that 0.5 into 0.50, it's a lot easier to see that 0.5 is the larger number. Let's take a look at this same concept in pictures. Which number is smaller, 0.59 or 0.8? Right off the bat, you might look at these numbers and say 8 is smaller than 59, so 8 must be the smaller number. But when you look at the colored in spots, you can see that in the 0.59, 5 tenths are colored in and 9 hundredths. And in the 0.8 section, 8 tenths are colored in. And you can see that 8 tenths is more than 0.59. There are more purple shaded areas than there are the blue. The question asked which number is smaller, so when we see this, we know that 0.59 is the smaller number. Let's practice this one more time. Graph 0.8 and 0.75 on the number line. Which number is smaller? So let's graph 0.8, which isn't on the number line, but 0.80 is on the number line, and 0.75, and find out which one is smaller. Since numbers increase in value as they move down the number line to the right, I know that since 0.75 is the furthest to the left, that makes the smaller number of the two 0.75. In this example, we're going to graph 0.07 and 0.1 on the number line. As you can see, some of the numbers are not in the number line, so we need to figure out where these fit. 0.07, I can see that there's 0.05. I'm going to count up. 0.06, 0.07 would go right here. And 0.1 is an equivalent decimal on the number line here as 0.10. Which number is greater? I can see that 0.10 is further down the number line, making it the greater number. Now we're going to start comparing numbers not using a number line, just simply by looking at the numbers. We'll be using symbols like this, greater than, less than, or equal to. To figure these out, I always move place value by place value to see which number is greater. So I always start on the very left-hand side. In this case, I'm going to start with my ones place value. The ones in the 7.5 is a 7. The ones in the 6.9 is a 6. Now I can see that 7 is greater than 6, so I already know that the 7.5 is greater than 6.9. Let's take a look at this example. When we look at our ones place value, I have 0 in both columns. Moving on to the tenths, I have 7 tenths and 4 tenths. I can see that 7 tenths is greater than 4 tenths. Therefore, 0.7 is greater than 0.4. Another similar question is 0.3 and 0.5. I can see that there are 0 ones in both numbers. When I look to the tenths, I have 3 tenths and 5 tenths. I can see that 5 tenths is greater than 3 tenths. Therefore, 0.5 is greater than 0.3. When looking at this symbol here, I'm wondering which way do I put it? The easy way to remember is that the mouth always opens up to the bigger value. So some people like to think of it as an alligator that eats the bigger number every time. So the mouth should always open up to that bigger number. Here we're going to compare 0.53 with 0.58. The first thing I do is look to the ones section, and I can see that I have 0 in both my numbers. When I move to the tenths, I have 5 in both. So now I need to move to the hundredths. I can see that I have 3 in this one and 8 in 0.58, which would mean that the 8 is larger than the 3, making 0.58 the greater number. In this next example, we're going to compare 0.32 and 0.6. Don't be fooled by the 0.6 and think that it is automatically smaller because there's less digits. Some people see it as 32 versus 6, which isn't the case. Let's start. Looking at the ones, there are zeros in both. Looking at the tenths, there's 3 in the 0.32 and 6 in the 0.6. That makes the 0.6 the larger number. Following the same procedures with these numbers, let's compare 0.2 and 0.44. Looking at the ones, we have zeros in both. Looking at the tenths, there's 2 in 0.2 and 4 in 0.44. I don't need to go any further. I know that 0.44 is the larger number. Our next example is 0.6 and 0.60. When I start with the ones, I see I have a 0. Moving into the tenths, I can see I have 6 in both numbers. I also have a 0 in the hundredths. That means this is an equivalent decimal, so I put an equal sign between them, just like this. In our final example, we're going to compare 0.4 and 0.43. When I start, I can see that I have zeros in my ones. When I move to the tenths, I have 4 tenths in both. Now, I then move to the hundredths. In my first one, 0.4, I know that this is a 0 here. So I have 0 hundredths. In my 0.43, I have 3 hundredths. That makes 0.43 the larger number. By this point, you can probably compare decimals pretty quickly. If there's any tricky ones, remember, just move place value by place value to figure them out. Good luck.